Hi, I am Lohith Kumar, a PhD student at the University of Bologna. My research focus is on isolated DC-DC converters for DC microgrids. DC microgrids can generally be classified into unipolar and bipolar configurations. In this context, the current-fed DAB with interface inductors proves especially useful. This configuration introduces different ZVS conditions compared to the conventional DAB. Therefore, we provide a ZVS analysis of an interleaved current-fed DAB for bipolar and unipolar DC grids. In a typical DAB, we often lose ZVS under light load conditions, especially when operating across a wide output voltage range. However, in current-fed DAB, the interface inductors can carry either DC current or no DC current depending on the load arrangement. When there is no DC offset, the ZVS range on the output bridge extends, allowing soft switching over a wide operating range. Thanks to the Tallinn University of Technology, we are able to experimentally validate this behavior. This is our experimental prototype. We have implemented the single phase shift control using an STM32 microcontroller. As you can see, this is the primary bridge and the secondary bridge, which are connected through a high frequency transformer. Whereas in the current-fed DAB, where there is no DC offset, the two interface inductors can be simply realized with a single inductor connected between the two legs of output bridge. In the conventional DAB setup operating under lower phase shift value and lower voltage gain value, we observe the loss of ZVS on the output bridge. This is evident from the drain source voltage and gate source voltage waveforms, which shows the output bridge switches are hard switching. There are also general waveforms here. Now, using the same operating conditions in the current-fed DAB configuration, specifically in the no DC offset case, the ZVS region is significantly extended and making sure that the output side switches achieve the ZVS. This result is clearly visible in drain source voltage and gate source voltage. From the general waveforms, we can also observe that there is no DC offset current in the interface inductor. This concludes the results, and the future work will include the DC offset case. Finally, I would like to thank to my colleagues and IEEE Industrial Electronics Society for giving me this opportunity.